time of flight, TOF mass spectrometry is an important analytical technique. A mixture of 3 compounds is analysed using a TOF mass spectrometer. The mixture is ionised using electrospray ionization, so that's quite important, the type of ionisation. The 3 compounds are known to have the molecular formulas shown below. Describe how molecules are ionised using electrospray. So the first thing is that the sample must be dissolved in a volatile solvent. What happens then is injected through a needle which is attached to a high voltage supply. As a result of that, as it passes through the needle, each particle in the sample gains a proton from the solvent. So your particle, your molecule, whatever it was, it's going to pick up a proton and it's going to become protonated, and that is how it's going to become charged in order to allow it to pass through the mass spectrometer. It says give the formula of the ion that reaches the detector first. So we want to find the lightest, because the lightest travels the fastest, and we'll get to the end first. So we go up and we have a look, and we can see that they're kind of being arranged roughly in order of the size. So the top one is definitely the lightest, so we want to pick this one, but we need to remember that we are adding a proton. So where it was C3H5, it's going to become C3H6, and then the rest of it we're going to copy, and it's an ion, so we need to not forget to put the charge on it. A sample of germanium, so we look on the periodic table and we find out that that is Ge, is analysed using electron impact ionization. This is high energy electrons knock off an electron. So give an equation including state symbols for the process that occurs when it's ionized. So we're going to knock off an electron to give us a charged species. In the mass spectrometer, we've got a time here. So this is our time. We've got a kinetic energy, so this is our Ke, and we've got a length, this is our distance, but distance needs to be converted, because look, we're going to need speed. We're going to use the kinetic energy equation that needs velocity or speed, and speed has to be in meters per second. So 96 centimetres, there are 100 centimetres in a metre, is 0.96 meters. That's our distance. We're going to use this to find the mass of 1 mole. So the first thing we're going to do is rearrange the kinetic energy equation to find the mass of 1 ion. So that would be 2 times kinetic energy divided by velocity squared. But we're going to need velocity, and velocity is distance divided by time. So then we can use our distance, 0.96 meters, divide by our time. Type that in your calculator. You can get this number. It's quite a big number, quite fast. Meters per second. Now we can put that into our mass equation. So 2 times the kinetic energy, which is 2.438 times 10 to the minus 15, divided by the answer that we've still got on our calculator squared. So I'm not actually going to retype that number. I'm going to use the calculator answer. I'm going to do divide by answer squared. And I'm getting 1.146 times 10 to the minus 25. And mass is in kilograms in this equation. So it told us that at the top. So we want the mass in grams of 1 mole. So what would this be in grams? So if we times by 1,000, we're going to get the answer to that in grams. But this is for 1 ion. So if we want to know it for 1 mole, we're going to times by the number that are in 1 mole. So we're going to multiply by Avogadro's. So again, I'm just going to keep it on my calculator and times by Avogadro's number. Getting 69.0 grams. So the mass of 1 mole is 69.0 grams. Now it wants the mass number. Now mass number is the number of protons plus neutrons. So it's always a whole number. Whereas the mass of 1 mole is an average, taking into account all the isotopes. Mass number is the number of protons and neutrons for an isotope, so for a specific one. So mass number is a whole number, 69.